Alright, today we're going to go over the review quiz 3.3, 3.4. Part 1 is so we're going to start at 1 and see how far we can get. Now remember, numbers 1 through 4, they're going to use the same f of x and g of x for all 4 problems. Now the first thing I'm going to do is I'm going to find the domain. So I'm going to find the domain of these two original problems, because remember, if you check the original problem, step 3 always says to check the domain of the original. So remember, the domain for the first one starts off as all the reals. Because I see a fraction exponent, remember that's even, because that little number on the bottom, right there, is even. That says I have to use the plus sign, because I can't use a negative. If I put a negative in there, I get error. So I use all the positive numbers and 0. Domain of G, same thing. Now remember, when it comes down to domain rules are pretty simple. The first thing you're going to look for is you're going to look for fractions, because your denominator cannot equal 0. So although we see fractions in both of these, none of them have a variable on the bottom, so they're not breaking this rule. Then we're going to look for radicals or fraction exponents. And then remember, that means no negatives. So because that's even, and same thing, so g of x, same thing, I have r plus and 0 because of this rule right here. Alright, and I'll come back to that when I go over numbers 1, 2, 3, and 4. So number 1 says I have f of x plus g of x, so the first thing to do is I plug in negative 3x to the 1/3 plus 4x to the 1/2, and then I plug in 5x to the 1/3 plus 4x to the 1/2. Since it's all plus signs, I don't have to worry about any of that, the parentheses doing anything. So remember, like terms have the same variable with the same denominator, so I combine negative 3 and 5 to get 2x to the 1/3. And then I cross them off just so I don't use them again. Then I use 4 and 4 to get 8x to the 1/2. Remember, this is a new function, that's why I put h of x there, so I have to put that h of x there. Then finally, the domain starts off with all the reals. Because that's even, I put the plus sign and 0, and it's not breaking any other rules, so I don't worry about it. And that's it for number 1. So now we have f of x plus f of x for number 2. So the first thing to do is put negative 3x to the 1/3 plus 4x to the 1/2 plus negative 3x to the 1/3 plus 4x to the 1/2. Because there's a plus sign in between, I just ignore all those parentheses. So I combine anything that has the same variable and same exponent. So I combine negative 3 and negative 3 to get minus 6x to the 1/3. Combine 4 and 4 to get plus 8x to the 1/2. Remember, it's h of x because it's a new function. I made it something new. And when I make something new, I got to put the domain in there because those are the directions. And because I have the even fraction exponent, I say it's r plus and 0. That's it. Alright, number 3, I have f of x minus g of x. So I put in negative 3x to the 1/3 plus 4x to the 1/2 minus, in parentheses, it's important that you put this in parentheses, I have 5x to the 1/3 plus 4x to the 1/2. Now because that second set of is in parentheses, I have to distribute that negative sign. So I make it minus 5x to the 1/3 minus 4x to the 1/2. Now when I combine my like terms, negative 3 and negative 5, so remember I say h of x, because it's a brand new function, is minus 8x to the 1/3. Cross them off because I'm done with them. 4 minus 4 is plus 0, so I don't even write anything. And so that's my final function right here. Now I made a new function, so I need the domain. It looks like all the reals. And although it's not breaking any rules, it's not breaking our fraction rule, and it's not breaking our radical exponent rule because it's r, I still put r plus in 0 because of original domains. Alright, number 4, we have g of x minus g of x. So I put negative 5x to the 1/3 plus 4x to the 1/2 minus 5x to the 1/3 plus 4x to the 1/2. Remember, I did put that in parentheses so that negative goes to both, so it becomes minus 5x to the 1/3 plus minus 4x to the 1/2. Those cancel, these cancel, so my new function is just 0. Now, even though it looks like it's not breaking any rules, my domain starts off as all the reals, but because of the original, I say it's r plus and 0 because of original functions. Alright, now numbers 5 through 8, we have two new functions. So we have f of x equals 4x to the 2/3 and g of x equals 5x to the 1/2. So because I'm going to use the domains, the originals for steps 3, I'm going to do the domains now. For f of x, the domain is all the real numbers because there's no letters in the bottom of fractions. And it's an odd fraction exponent. G of x, domain, it's all the reals that are positive and 0 because there are no fractions in the bottom of a fraction, and it's an even fraction exponent. Alright, so number 5, g of x times f of x. So I have 5x to the 1/2 times 4x to the 2/3. I do 5 times 4 to get 20. I have matching x's, so I add the exponents. I do 1/2 plus 2/3. 1/2 is 3/6, 2/3 is 4/6. So I end up with h of x equals 20 x to the 7/6. Domain is all the reals, and because that's even, it's r plus and 0. And that's it. Alright, number 6, we have g of x times g of x. Now remember, g of x is 5x to the 1/2. So I put 5x to the 1/2 in twice. 5 times 5. So I remember I have a new function because I'm building a new function. I have 25, and then I add 1/2 and 1/2. Well, and a half and a half as a whole, so my new function is just 25x. So the domain is all the reals just by what it looks like. But because of my original function, I have to go with all the reals that are positive and 0, because we are never allowed to use negative numbers to begin with, even though you could plug a negative number in at the end, so it still is what we started with. So because of the originals, we have to say r plus and 0. And that's it. Alright, number 7 is g of x over f of x. So the first thing I'm going to do is I'm going to write 5x to the 1/2 all over 4x to the 2/3. Now, I can't do anything with 5 over 4, so I'm just going to leave it as 5 over 4. Now, I notice I have x and x, so I do x and I do 1/2 minus 2/3 because now we're dividing. So 1/2 minus 2/3 is x to the negative 1/6. Now remember in class we said if you have a negative exponent, it's like what happens when your rent's negative. If your rent's negative, you get kicked out and you have to go live in mom's basement. So 5 paid his rent, so he gets to stay upstairs where he was at. And then 4 is already living in mom's basement, and now X has to go live in mom's basement and with the 1/6. So now I have to find the domain. Now because I have the fraction in the bottom, because the X is in the bottom, I have to say all the reals and X cannot be 0. Because if I plugged in 0, it would give me a divide by 0 error. Then, because that's even, I've got to put the R plus. So that's my final answer. Number 8, I have g of x over g of x. So I put 5x to the 1/2 all over 5x to the 1/2. Now, although everything cancels, so my new function, because 5 over 5 is 1, and x over 1/2, 1 over x, 1/2 is 1. My final function is h of x equals 1. My domain is all the reals, but I started with a fraction. I started with a fraction with a letter in the bottom. So I cannot pick 0 to start because it would pick 0 in the beginning, at the bottom of a fraction. So you can't do that. So the first thing to do is pick cannot be 0. Alright. Now I put R plus because of the original. So that's my final answer right there. And that's it for number 8. Alright, numbers 9 through 12. I have f of x, g of x, and h of x. Although it really doesn't matter because they don't tell you to state the domain, we could always do the domain again. Domain for f of x is all the reals. It's not breaking any rules. Domain for g of x is all the reals that are positive and 0. And h of x is all the reals because the letters on the top and there's no fraction exponents. Alright, number 9 is g of f of 2. So the first thing I'm going to do is I'm going to start with g of big blank space, because I don't want you guys to get confused on whether to pick g or f. So when I do g of big blank space, I just plug in whatever g of x is, except instead of x, I put a blank space. I put 5 big blank space to the 1/2. Because I'm only allowed to put an x there, next here, if there's an x in the parentheses. But since there's not, that's how we leave it. Now the next thing we do is we put g of f of 2. Well, if f of x is 3x plus 2, f of 2 has to equal 3 times 2 plus 2, because instead of x, I have a 2 there, so that's why there's a 2 right there. So I'm going to plug in all that right into this parentheses, and now I'm just going to simplify. 3 times 2 is 6, 6 plus 2 is 8, so I have 5 times 8 to the 1/2, so I plug it into my calculator, just the way it is, and I end up with 14.142. And that's it. Alright, 10, very similar. I start with g of big blank space. So if g of x is 5x to the 1/2, when I put g of big blank space, I just put 5 big blank space to the 1/2. And if h of x is equal to x minus 2 all over 5, that means h of 8 is 8 minus 2 all over 5. So I put g of h of 8, and I put 5. Instead of h of 8, I put 8 minus 2 all over 5 to the 1/2. So I have g of h of 8 equals 5, 6 over 5 to the 1/2. I plug it all into my calculator, so I get g of h of 8 equals 5.477. And that's it. Alright, so I have f of 7. So remember, if f of x equals 3x plus 2, means f of big blank space equals 3 big blank space plus 2. Now if I'm going to put an f of 7 in there, inside the parentheses I put 3, 7 plus 2, and I still have my plus 2. Notice that's why I like that I leave this line here so I can make sure I didn't forget anything. Now I do 3 times 7 is 21 plus 2, so I get 3 times 23 plus 2. I get 3 times 23 is 69 plus 2 is 71. So f of 7 equals 71. And that's it. Alright, 12. I have g of negative 5, so I start off with g of big blank space. Remember, if g of x is 5x to the 1/2, that means g of big blank space is 5 big blank space to the 1/2. So then I put g of negative 5. So I have 5, and in parentheses I put 5, negative 5 to the 1/2. And remember, it's still all to the 1/2. So now I'm just going to do some simplifying. 1/2 and 1/2, that becomes 1. So I have 5 times 5 to the negative 5. So the 1/2 goes to both. So I have 5 to the 1/2 and negative 5 to the first. And then they're all 5s. So I'm just going to add up all of them. Remember, there's a 1 there. So I have negative 5 to the 2, or to the 5/2. And so that's my final answer. So my final answer is just g of negative 5 is negative 5 to the 5/2. And that's it. Alrighty, so 12 through 16 is going to use the same three functions, f of x, g of x, and h of x. And we are going to need the domain, so it's going to be important to know what the domain of these functions are. Alright, so f of x, I see a negative exponent, which really means this is 3 over x, which means I have all the real numbers, but I can't pick 0. So I say x cannot equal 0. G of x, it's not breaking any rules. There's no fractions. There's no radical exponents, so I know it's all the real numbers. H of x, all those are fraction. There's no letter in the bottom, so it's all the reals. And there's no radicals, so it stays all the reals. So those are my domains for 12 through 16. I will use those for step 3 when I check the domain. Alright, 13. 13 is g of f of x. So remember, I'm going to start with g because I see g first, so I put g of blank space. Remember, g of x equals 2x minus 7. So I will start with g of blank space. I put 2 big blank space minus 7. Now I put g of f of x. And if f of x is 3x to the negative 1, I put 3x to the negative 1 in that parentheses. Notice I keep everything exactly the same. I like to leave this line. I like to leave that line blank, so I have something to look back to make sure I don't forget anything. A lot of people forget this minus 7. So I put 3x to the negative 1 in there. It's all multiplication, so it becomes 6x to the negative 1. Now remember, you're not allowed to have a negative exponent, so the negative exponent is like when you don't pay your rent, so they get kicked down into mom's basement. 6 does not have a negative exponent, that's why they stay up top. So remember, that's my, I put my label here. This is your label. You're telling me you just did a composition. That's why you write this there. Now the last thing you gotta do is tell me domain. It starts off as all the reals. Because there's an x in the bottom there, I say x cannot equal to 0. And that's it for this actual ending problem. But then I check the originals, and the originals are no different. So therefore, this is my final answer with my correct domain. So now I have g of h of x. So once again, I see g, so I put g a big blank space. And if g of x equals 2x minus 7, the first step is going to be 2 blank space minus 7. Now when I put in h of x, I need to know h of x equals x plus 4 all over 3. So I put in 2, and then I put x plus 4 all over 3 minus 7. So in this step, I'm going to do a couple things. I'm going to just continue with my label, just because I like labeling things. The 2 is going to go to the top, so it becomes 2x plus 8 all over 3. And I'm going to turn 7 into 21 over 3, because those are equivalent fractions. 7 over 1, 21 over 3. So this makes g of h of x equal 2x plus 8 minus 21 all over 3. So my final answer, 8 minus 21 is negative 13, so I have 2x minus 13 all over 3. So then, I got to do with the domain. Domain is all the reals. I check g of x, that domain's all the reals. I check h of x, that domain's all the reals. So the whole domain just stays all the reals. And that's it for 14. Alright, 20. This time I start with f. So remember, if f of x is 3x to the negative 1, I put f a blank space equals 3 blank space to the negative 1. Now, like I said, I like to leave this line blank because I like to compare what I had. So I'm adding f of x, so I put 3x to the negative 1, to the negative 1. Now, many of us are going to try and do 3 times 3. You can't. That negative 1 has to go to both because exponents happen first. When I do PEMDAS, I have to do exponent before I do multiplication. So I get f of x equals 3 times 3 to the negative 1 times x, because negative 1 times negative 1 is positive 1. Now, this is the only guy who didn't pay his rent, so he's the only guy who goes to the bottom of the fraction. Everybody else stays on top. Now I have the 3's cancel, so my final answer is f of x equals x. Now the domain looks like all the reals, but because we started with this, I have to say x cannot equal to 0 because of the original. Alright, so that's my final answer right here for 15. 16, I have g of x. Once again, g of x is 2x minus 7. So I start off with g, that's g of blank space, so I put 2 blank space minus 7. Now g of x is 2x minus 7, minus 7. I distribute the 2, I get 4x minus 14 minus 7. So then I end up with 4x minus 21 as my final answer. Domain looks like all the reals. I checked the originals. It is all the reals, so that's my final answer. That's it for 16. Now remember, for 17 through 20, we have to follow these steps. Where step 1 is switching x and y. Step 2 means you're going to use PEMDAS backwards to solve for y. And step 3 means you're going to write f inverse of x for y. So that's what we're going to do. Alright, 17. I have y is equal to 4x minus 1. So step 1 says switch x and y, so I put x equals 4y minus 1. Now I solve for y in step 2. That's why I add 1 to both sides. I have x plus 1 equals 4y. Then I divide by 4. I divide by 4. I get y is equal to x plus 1/4. So my final answer is step 3. F inverse of x equals x plus 1/4. And that's it for 17. 18, I have y is equal to negative 3/5 x plus 7/5. So step 1 says I'm going to switch x and y. So there's step 1. So I have x is equal to negative 3/5 y plus 7/5. Now what I'm going to do is I'm going to multiply everything by 5 so I can get rid of all these fractions, because I know you guys don't like fractions. So I have 5x equals negative 3y plus 7. Now I'm going to solve minus 7 from both sides. I get 5x minus 7 equals negative 3y. Now I divide everything by negative 3. I can't just divide 5x or just divide by negative 7 by 3. The 3 goes to both. So my final answer is y equals 5x minus 7 all over 3. And after step 3, I put f inverse of x. That's what the negative 1 there tells me that you know it's an inverse, is 5x minus 7 all over 3. And that's it for 18. Alright, number 19. I have y is equal to 5x plus 3. So the first thing I'm going to do is I'm going to have x equals 5y plus 1/3. Now I'm going to multiply everything by 3. because that's going to get rid of that little fraction. I know you guys don't like the fractions, so I have 3x 15y plus 1. I multiplied everything by 3. All right. Now I'm just going to solve, so I minus 1 from both sides, so I get 3x minus 1 equals 15y. Divide by 15, divide by 15. I get y equals 3x minus 1 all over 15. So step 3 says I need to put f inverse of x in there, so I say f inverse of x equals 3x minus 1 all over 15. Alright, that's going to finish that. 20. We have 12x plus 7. Y is equal to 12 equals 7. So step 1 says I'm going to switch x and y. So I write x is equal to 12y plus 7. Now remember, PEMDA's backwards. So I don't see any subtraction. I see addition. That's why I subtract 7 from both sides. I get x minus 7 equals 12y. I don't see any division. I see multiplication. That's why I divide both sides by 12. Remember, this is all step 2. Step 2 right here. So I end up with y equals x minus 7 all over 12. And then remember, step 3 says you have to write f inverse of x. That's you telling me that that's the inverse. So I have f inverse of x equals x minus 7 all over 12. So you're telling me that's the inverse, and that's it for 20. And that's all we're going to do tonight. So part 1 of this video was numbers 1 to 20. And that's it.